Check for dropped. Hey. Hello, if you have shown up. I just wanted to make sure it worked before the actual time. I have not dropped a frame yet. A lot better than last time. Hello. The other two people lacking in. Oh, there he is. Will Euler's rule be on the test? Absolutely not. Now that's a that used to be a Calc AB topic and is a Calc B topic now, so I get to avoid that one. Not that it's super hard, but it's tedious, and so no. Did that show up on anything? Pretty sure I yeeted it off all of the view materials, all the notes and everything. Might still be stuck on my website. That's it. I'm cutting out a bit. That sound quality. Wonder if my noise gate is too specific. Definitely haven't missed any frames. YouTube says I'm perfect. Check that. Thought on the practice test and your extra practice website. Huh. IFFIC. Rific. Still ific? Perfect. Maybe I should send an email out. Or maybe it's just gonna be Carter, Amy, and I Doing review stuff. Be fine. Yeah, I'm gonna send out an email. Just real quick. Oh goodness, what did I just do? Whatever. Courses. Oh, we got more people here now. Matthew was the other probably silent person. Hayden's here now. Mia, Lucy. Don't slack on second period, Kennedy. I've already written the tests. I haven't proofread them yet. But there's fewer problems that can happen when everything is free response because they're all solvable. I did originally write a question that would have been too hard to integrate, but that is no longer the case. Okay, so where do people want me to start? So hit me with some questions or something. And hopefully only Amy's computer is censoring my consonant. What words are like all consonants? Glyph? The last box thing without a number, 5, 10, and 11. Cool. So, it looks like there are multiple 5s. So I'm gonna start with the last box thing without a number? Let's see. 5 on multiple choice. Question 11 on the front review. 5 on multiple choice. There are 2 5 multiple choices. No. So this 5. Okay, cool. So a particle is moving along a graph with a curve, blah. At the instant when the particle crosses the y-axis, the y-coordinate of its location is changing at the rate of 12 units per second. Find the rate of change of the x-coordinate of the particle's location. So, first things first, I want to figure out where it goes through the y-axis for this thing. So that where it crosses the y-axis is when x is 0. So that's at y equals natural log of. That's where that thing does go through. The y-axis. And then it says the y-coordinate of its location is changing at the rate of 12 units per second. So I gotta take the derivative of both sides. So this is a related rates question. I just realized there could be an issue here. Nah, it'll be fine. So the derivative of natural log of 4x plus 3 is just 4 over 4x plus 3. And then if we plug in natural log of 3, we should get, what, 4 natural log of 3 over 4x. So 4 natural, wait, 4x is, oh, did I just goof? I don't know what x is. Oh no, it's 0. So actually, no, I'm chilling. It's 4ln 3 over 3. Wait, where did I get that ln 3 on top? What am I doing? Okay, I am being a bad right now. If you plug in 0 for x in this thing's derivative, you get 4 over 3 dx dt. Because the derivative... Oh my gosh. I am an absolute unmitigated disaster. I need to start this part of the question over. I finally put my brain on for today. What happens when you write tests all day? Like, lose all your brain stuffs. Okay, I'm making a comeback here. So first, the derivative isn't this. This is profoundly wrong because it's 4 dx dt over 4x plus 3. I totally forgot the chain rule on this side, and that was really sloppy. Because it tells us x is changing, as is y. So I need to plug in, I need to get a dx dt or a dy dt whenever I take the derivative of x or y. So now that I know, have this derivative and it's actually right, I gotta plug in 12 for dy dt, because that's the y coordinates rate of change. And then I gotta plug in 0 for x, which is would give me 4 over 3 times dx dt. And then I just multiply both sides by 3/4. And that's where I get 9 units per second, which is the answer to that. And yes, you divide the 12 by 4/3. That is absolutely right. Too hard to integrate based on your Amy, the question I goofed up was actually it wasn't that it was too hard to integrate, it was that it was impossible to solve for y, and that's what the question was asking for. So that's not nice. And so I got rid of that question. Okay, I'm gonna head to 11. I'm going to assume 11 is this one. Because that would be a decent assumption, I think. So it says the volume of a solid obtained by revolving a region enclosed by the ellipse x squared plus 9y squared equals 9. So let me just draw this ellipse real quick. If you plug in 0 for y, you get x squared equals 9, so it goes to 3 and -3 on the left to the right. And if you plug in 0 for x, you get 9y squared equals 9, so it goes through 1 and -1. Means our ellipse looks like that beautiful thing I just drew. And now we're rotating this thing around the x-axis, so we run into this issue where really we're only rotating around one part of this, because if we rotate around the x-axis, the stuff on the right side is going to overlap with the stuff on the left side. It's not like a double count it. It just creates a shape that is like a, I guess it's just an oblate spheroid. I think that's what you call those when they're ovalish spheres. So now that we have figured out that that is how that works, perhaps, we just need to figure out how we're going to write the integral for this. So we're revolving, so it's definitely going to be a pi r squared sort of situation. We're going around the x-axis, so we know we use our x bounds. Since I know I'm just rotating this junk here, it's from 0 to 3. I do from 0 to 3. Did I just goof? Yeah, I'm going around the x-axis, so I'm actually going all the way along this top piece instead. Yeah, that's sloppy. So I'm going from -3 to 3. Okay, so there is a lazy way to do this. You can just, you can just do 2 pi times the integral from 0 to 3, but I'm not going to do the lazy way. I'm going to do like the official way where we actually count all the pieces. Let's get rid of all that garbage. What I'm doing is I have decided that if I just rotate this top piece around the x-axis here, it'll create the oblate spheroid shape thing here. So I'm actually integrating from -3 to 3, not from 0 to 3. But you can also multiply by 2 and do the integral from 0 to 3, and that's legit. So follow your heart on this one. Anyways, so now that I have this figured out, I just got to figure out the height of this thing. And so all I gotta do is solve for y. So I subtract x squared, and I get 9 minus x squared equals 9y squared. Then you divide by 9, and you get y squared equals 1 minus x squared over 9. And then you get y equals plus or minus the square root of this thing. So the nice part is, no washers here. This is just disks. We're attached to the thing we're revolving around. And since y equals the square root of this garbage, when I plug that into r squared, I'm just going to get this 1 minus x squared over 9. So that's the only thing that I'm integrating. And now you just integrate to like x minus x cubed over 27. And you plug in -3 and 3. Or plug in 0 and 3 and multiply by 2. What do you get? 3 minus 1, so 2 pi. So the answer was 4 pi. Chillin'. All right. So I've done 5 and 11. I have not done 10. That was asked for. Okay, so we have a differential equation. Find y of t. This is the part where you solve. So can I write over here? Oh, no, it gets rid of it. Okay. So I need room to solve this differential equation. Why did you write 4 pi, Carter? That is the answer. But, yeah, at least that's the answer I got. So if you separate variables on this one, you get dy over y equals u2b, sure. And I still gotta do like that last question. People asked about that one, so that's fine. So what I'm gonna do here is I'm gonna be a little bit on the distributing side here while moving the y to the other side, just to make life a little easier for me in the long run. And this is multiplied by dt. Okay, so this is the separated variables where this is a 60, the least convincing 60 of all time. And if you integrate dy over y, you get natural log of y equals, pretty easy integral here, 1 over 5t minus t squared over 120. And then you just e both sides and you're good to go. Because you get y equals, and that's pretty cool. So y equals e to the 1 over 5t minus t squared over 120. All right. Then you plug in the initial condition, which is that at 0, you get 3. I totally forgot the c. So there was supposed to be a c in front of this e. And turns out when you plug in 0, e to the 0 is 1. So all you get is 3 e to this garbage. And that's the answer to that one. Then you just plug in infinity. And if you plug in infinity, the t squared term's going to be dominant. You're actually going to a negative exponent for e, which means as you go out to infinity for this function, it's going to be going to e to the 0. Or sorry, e to the negative infinity goes to 0. So we're actually going to 0 for this function. This function's getting smaller. This function looks a little bit like, yeah, whoa, that's really bad. It's a declining exponential on this side. I guess it'd be declining on both sides, so it'd actually look more like this. Yeah. More accurate. Something like that. All right. And you forgot plus c. I did forget plus c. That was bad. But I added it there. Writing with a mouse makes me so angry that I forget things. Feels bad. Like, look how bad my handwriting is. Oh, Lord. All right, so, did I skip any of the questions on here? The last thing without a box. This homie here at the end. Which at-bat was the hardest on this? Let's see. Revolve around the x-axis, revolve around the y-axis. Probably the y-axis is the hardest here. Because the two x ones are pretty easy. You just do top curve minus bottom curve. And then, for the other one, the big R would actually be top curve plus 2, and bottom curve plus 2 would be little r. And that's how you do the two, those two boxes. Big R and little r, either just the functions, or for the second one, plus 2. The last one is probably the hardest, because you're revolving around the y-axis, and when you revolve around the y-axis, you actually have a different outside r, depending on whether or not you're before 2.5 or after 2.5. So if I were to write these integrals, I would have to do one integral from 0.1 to 2.5 for the bottom function, 1 over 10 to, oh gosh, I didn't solve for y. Oops, I almost made a major snafu. I need to solve that bottom equation for y first. So I have to multiply by 10, then square root, so root 10y equals 2x plus 1. And then I gotta subtract 1 and divide by 2, so it's root 10y minus 1 over 2 equals x. What a beautiful, beautiful thing. So that's actually what I'm plugging into this thing, is this thing squared. dy. And then I'm adding the integral from 2.5 to 5 of the top function if I solve it for x. Another fun experience here where I get to solve for x. So y over 5. Then I undo the cosine by inverse cosining. And then I divide by pi over 6, which is the same as multiplying by 6 over pi. There's that beautiful thing. That's my second r value. So it'd be that thing squared. And I need to use a different mouse setting that doesn't move around as much. One. That looks tenable. All right. So 6 over pi inverse cosine of y over 5 squared dy. Better. Have I created any good quotes? I'm not sure I have, honestly. Hopefully, my thing just said, did I drop frames at some point? My thing said I dipped down to like 2 viewers, but I've dropped 0 frames. So I don't think so. Oh yeah, it was lying to me. Dirty liar. So yeah, if you add these two pieces together, you can get the y. Writing with the mouse makes me so angry that I'm skipping things. Did I say that? That's unnecessary and I shouldn't say that. That's bad. Okay. So hopefully that answered people's questions on this one, despite my absolutely horrendous handwriting. Okay, Sydney's here, so we have the Kennedy quota meter going off. Are you forgetting a pi before the second integral? Yeah, good catch. There it is. Oh, speaking of, shout out, the quiz. So, I should talk about that quiz before I give the shout. Oh, no, I can give the shout out. The only people to even get close to getting the second question right on second periods and the first question right on fourth periods were Rachel Hokie and Sydney Kincaid. Those two people. Sydney actually got it right, and Rachel was off by 1 minus sign. So that was pretty sick. So good job to you two, if assuming Rachel's even here. But I know Sydney's here, so shout out. Okay, so that brings me to the free response, I think. Is what people want next to be on the free response. I guess that's this one. You do 4C. Probably. So I assume it's this 2B. Whoever said that one. Go Rachel H. Gosh darn it. The two Rachel H's are just Rachel H's. So 2B on FRQ. Okay. So cross section's perpendicular to the y-axis. Are isosceles. Oh, this is perfect. This is basically our quiz. Almost exactly, except it's easier to solve for x in this one. So if you were to do this one, hopefully I did this right on my. Did I do this right on what I uploaded? Now I'm checking. I don't have it with me. Hopefully. All right. So to start off here, if we're going perpendicular to the y-axis, things get a little gnarly here because these are up into 3D or isosceles triangles in the top part, and these are them in our bottom part. And you may notice the curve is both the outside and the inside of this part, whereas it's the curve and the line for the top part from -2 to 1. So I have to do two separate integrals on this. So what I'm going to have to do is 1/2 base squared is the area equation of a isosceles triangle or isosceles right triangle. Yikes. If it wasn't right, this would be very hard to do. I'm going to be very, very clear on that one on the test. I know because I've written it. So I'm going to have two different integrals. I'm going to do the easier integral first, which is the top one. It's going to be 1/2 of, let's see, if I turn my head 90 degrees to the right looking at this, my top curve is the curved part, and my bottom curve is the line. So I'm going to solve these two equations for x, and I'm going to put the curved part on top, square root both sides, and we get plus or minus the square root of y plus 3 equals x. And we're going to want both the plus and the minus parts for the second integral. But for our first integral, we're just using the plus one because we're using the one that's like farther to the right. And then if the other equation's like really easy to solve, x plus y plus 1 equals x. My handwriting's improved since I switched my mouse setting. This is good. So now I just plug this in. It's going to be the outside part, which is square root of y plus 3, minus the inside part, which is y plus 1. And that's squared. Oh, goodness. Parentheses around that y plus 1, or subtract both of them. And parentheses squared for base squared, where the base is these things subtracted. And then I have to... Oh, and I forgot the bounds. That happens from -2 to 1. And then I have to add to this 1/2 for the integral from -3 to -2. And in this section, both the curve is both parts of the cross section. So the base is square root of y plus 3 minus a negative square root of y plus 3, or just 2 square root of y plus 3. We're going both directions the same distance on this one. And sick. If you add these two together, you're good to go. Those be the answer on that. Hopefully that helped. I guess I can go to 4C. Assuming I know where that is. Oh, this 4C. Alright, let's see this. It looks like we're solving a differential equation, because it asks for g. Find an expression for g of t. So I actually have to integrate this garbage right here and get something. So if you separate variables, you get dg over g minus 27 to the 2/3 equals -1 dt. Okay, so this, I could integrate this, but this is not where I want to integrate, at least the left side. The right side, sure, -t plus c. Oh, Nick Reagan. Oh, that kid sucked. Oh, man. So, g minus 27 to the 2/3 on the bottom is the same as g minus 27 to the -2/3 on top. So I can just yoink this out and put this on top. If I do this, I just raise the power by 1, divide by the new power. So g minus 27 to the 1/3 over 1/3. And this looks totally hunky-dory except for the fact that I have not solved for g. So I so I gotta multiply both sides by, it looks like, 1/3. So I get -1/3 c plus a new c equals g minus 27 to 1/3. Then I cube both sides, and I get g minus 27 equals c minus 1/3 d cubed. Okay, maybe my handwriting hasn't improved that much. And then you just add 27 both sides and you get g. So g is 27 plus c minus 1/3 t cubed. Sick. G of t found. Now the initial condition is that if you plug in 91 and 0, 91 for g and 0 for t, you want to try to get what c is. So that's 91 equals 27 plus c times, you plug in 0, this becomes 0. So, oh, goodness, I just messed up. That c is not a parenthesis. If you plug in 0 for t, you just get c cubed. So I'm just going to write that. There we go. So now I can just subtract 27 from both sides. So 64 equals c cubed. So c is 4. Is it a negative on the bottom? It was a positive on the bottom because I divided by g minus 27 to the 2/3 on both sides, which became a negative on top. So no, the power was negative on top when I moved it to the other side. Hopefully that was the question you were asking about with that. Anyways, now that c is 4, I can just plug in 3 into this equation, and I get g equals 27 plus 4 minus, if I plug 3 in for t, I just get 1 to the 3rd power. So 27 plus 27 is 54, so that was the internal temperature of the potato at time equals 3. The accurate one, the one using the model. So hopefully that answered that question. We do 4b on that one too. Yes. If you take the derivative of dH dt, you get negative 1/4 times dH dt, so times negative 1/4 times h minus 27. So again, the derivative of this is just negative 1/4 dH dt. And then you plug in dH dt and you get negative 1/4 times negative 1/4 times h minus 27, which ends up being 1/16 times h minus 27. Sick, that's the second derivative. So now I need to use it to determine whether or not my answer in part A is an underestimate or an overestimate of the internal temperature of the potato at time equals 3. So here's the deal. This thing tells us, because we know the temperature of the potato is always greater than 27 for all my times where t is greater than 0, I know this is always positive, which means I know that I'm concave up. Because when the second derivative is positive, my graph is concave up. And literally any tangent line you draw to a concave up graph is going to under approximate. So it's under. Under. So that's it. Dylan. Anything else? 1C. That's back on the free response, isn't it? Yes. So, solving this differential equation. Is that the only way to find that out? Let's see. Is that the only way to find that out? Kind of. You need to know the concavity. Anytime it asks if a line is an under or over approximation, the second you know the concavity at the point, you know whether or not it's an under or over approximation. So that is the play. And this one even told you to use the second derivative, so yeah. There's probably other ways to figure it out, but they're probably less elegant, and so you probably shouldn't use them. Sure. Okay. So if I factor out an x here, I get this on the right side. So now if I separate variables, I get y over y squared plus 1 dy equals x dx. So right side, easy money. X squared over 2 plus c. Left side, a good old-fashioned u-sub question. So if you make u the bottom, the top is half of the derivative of the bottom, because the derivative of the bottom would be 2y dy. And so I have half of that on top. So I can actually rewrite this as like an integral of 1/2 du over u. You may be able to notice is exactly a natural log integral. So if I integrate this, I just get 1/2 natural log of u, which is y squared plus 1. Now you may notice in my answers for this, I use parentheses instead of absolute values here. And you can do that because y squared plus 1, always positive. So if you have absolute values, it's completely ineffectual because it's always positive, so it's just superfluous. You can leave them there. It's not wrong to leave them there, but I got rid of them. Then you multiply both sides by 2, and you get x squared plus a new c equals natural log of y squared plus 1. You e both sides, you get y squared plus 1 equals c e to the x squared. You subtract 1 from both sides, and you get y squared equals c e to the x squared minus 1. I think this is a pretty good spot to solve for c, because we're just going to square root and pick the positive one after this. So I'm just going to say 4 equals c e to the 0 is 1 minus 1. So c is 5. And now that we know this, we're chilling. We just plug 5 back in. So y equals 5 e to the x squared minus 1. And we now last step. Oh, this is y squared. That's what. We square root both sides and we get y equals the square root of 5e to the x squared minus 1. Is that answer? Lee, who do you think is the hottest president? I'd have to go with Joe Biden. He's the only current president of this country. So, yes, if you're the only one, you get to be the best looking, apparently. And the worst looking, sadly. Any other questions? Or are people like, yo, I got this. We chillin'? I think I actually hit a bunch of the order on this is really questionable. Who was the hottest president and why was it John F. Kennedy? Probably because he was he the youngest? I think he was the youngest. Anyone younger? I haven't taken US history in a while, so I don't know the answer to that question, but probably go with Taft if I had to like give an answer of history of presidents. Because breaking up Standard Oil is pretty hot. So go with that. Okay, so 6. Do I have 2 options for 6? No, I just have 1 option for 6. Kind of. Oh, this 6. Yeah, it's probably this one. So this question's like baby medieval. So if you integrate f, you get big F. And if you evaluate big F at 0 and 6, you would just get big F of 6 minus big F of 0. It was Roosevelt? I don't think so. I thought it was. I'm pretty sure it was Taft. My buddy and I were talking about this the other day. Oh, Teddy was the youngest. Really? Huh. Like one of my top 5s. All right, so f of 6 minus f of 0 is that. Then for the second integral, if you were to integrate f of 6x, you get big F of 6x over 6. And we're plugging in 0 and 1, so we would get big F of 6 minus big F of 0 over 6. Which, if we check these out and compare these, I can see that the second integral is going to be 1/6 of the first integral. So if the first integral equals 12, well, then the second integral equals 2. So that's why it's that one. Hopefully that answers the question. 2 for... I did 4C. Check it out. Guess I erased? No. This is the end of that one? Where was the step where I actually wrote G of T? Maybe I never wrote G of T. Huh. Probably just got lazy. Let's see. Hopefully that was the right 6, Sophie. You go over the slope fields question 7 on the free response worksheet. There was a question 4 on the free response worksheet. Oh, I guess there was. Oh, I did see here too. Check it out. Got the Funk Soul Brother again. Question 7. So, the slope fields question. Okay, so this one's a bit of a fun process because there is some definite narrowing down. So where I started was I'd recognized that there were two parabolas. One was around 0, and the other was around -1, where it has its turnaround. So it's like, one's like a x plus 1 squared, and this one's like an x squared sort of thing. So I can see that the one that's around 0 is going to go right here. Bottom question, it doesn't have a number. Okay, I'll pop over there after this. They have done that one. I'm very confused. Anyways, so the other one that looks like it's a parabola looks like this one right here. And you may notice if I plug a -1 into this, I get 0 for the slope. So this checks out also. So this one's G. Okay, cool. So I got the two easy ones out of the way. Let's yoink those. Second one I'd call easy and wrong. Should have edited this. This one should be y prime equals y minus x, I think. Or x minus y. Which one? X is -1. It's y minus x. This is right. But it's y plus x written here. Yeah, that's incorrect. However, these ones where we add together, that's where we have like the line that goes through this, and where we have 0 slope at like 1, 1, and at 2, 2. So this should have been y prime equals y minus x, and it should have been d. But it wasn't. You may have eliminated until you got to that point, but that one was a little janky. Okay, so now I'm going to look at my next one. Y prime equals y. So for this one, I have 0 slopes when y equals 0. So if I look around at my graphs, I got 0 slopes here at y equals 0. I got 0 slopes here at y equals 0, here, and here. So this is currently, based on that analysis, like a 1 and 4. Now I can kind of rule out this one because nothing's happening at the origin here, and this thing has no issues at the origin. And in fact, its slope is only dependent on the on the y value of the graph. So I can rule out this one because this one, for any given y value, the slopes aren't all the same. You can tell here. So this one is definitely not the one I'm on right now. So now I'm between these three: C, F, and H. And you may notice we got little slope, medium slope, big slope. H being little, C being medium, F being steep, but they have very similar characteristics. So I'm going to look at all of my ones that look very similar to this one. And this one looks really similar. And the last one that looks really similar is this one. So the reason why these look similar is they all have y prime equals y, but one of them is multiplied by 2, one of them is multiplied by 1/2, because the 2 is on the y prime side, and one of them's in the middle. So I just put the middle one is C, the steeper one is F, and the less steep one, H. Sick. Okay, get rid of these ones. I have 3 left to go. So next one here, if I divide by x to the other side, I get y prime equals 1 over x. Cool, this is like a natural log graph, so you could probably, if you knew natural log, recognize that it's this one, because that's what natural log looks like. But let's say you didn't know that. Well, first things first, if we plug in 0 for x, we get undefined slope. Checks out. Seems good. Also, all of the slopes for any given x value are all exactly the same. That definitely rules out these ones. So it has to be A. Because the slope is only dependent on x, for any given x value, the slopes are all the same. It doesn't matter what y is, x determines slope. Okay, 2 left. I got, what, B and I. So next one, y prime equals y over x. So this one should have straight up and down values when x equals 0, because that's undefined slope. And I can see this one has that characteristic, so I can immediately assign I to this one. And the last one, we'll just check this out real quick. It's x over y. That's what y prime equals. And so when y equals 0, we're flat lines. And when x equals 0, it's straight up and down. And so that one is B. And sick, that's all of them. So hopefully that was a good explanation. As far as this one goes, like why it's over 6, if you integrate f of 6x, you get big F of 6x over 6. This is why it's 1/6. It's like divided by the chain rule or doing u sub gets you that fraction. And that's why it's divided by 6 and not exactly the same as this other one. Because for this one, if you integrate, there's no chain rule or u sub for the f of x. So hopefully that helps. Wait, JK, it's FRQ2 on free response worksheet. Oh, C on this one. I haven't done C on this one yet. So if you revolve over y equals 5, it's like way up here. And this is big R, this is little r. So we're actually ready to rock and roll like right away on this one. It's pi from x, -1, to x, 2. Our bounds are in terms of x. And this first distance, the farther distance, is 5 minus the height of the curve, which would be 5 minus x squared minus 3. Be very careful that you distribute these negatives or use a parenthesis on these sorts of questions. This is an area where a lot of people are making mistakes. And that would be big R. And then little r would be 5 minus the height of the line, which would be 5 minus x minus 1 squared. And that's that integral. That would be the one that works. 5 minus, because it's 5 minus the height of the curve. It doesn't matter that it goes below the x-axis, because 5 minus a negative number is 5 plus that distance. So it actually works even when it dips below the x-axis. So no problems there. Hopefully that's the one you wanted me to do. Man, how old was Teddy when he got elected? Teddy Roosevelt was 43. JFK was 45. So light edge there. Can you publish keys for these? Yep, they're in the module. The second to last one, like Amy said. I can show where they are also. You have not located them. So pull my browser over. This is under modules, under my Canvas page, and this is the solutions to the free response thing, and this is the solutions for the review worksheet, along with blank copies for these above them. So hopefully that's that question. This channel isn't Liberty miscellaneous and stuff. Oh, because people were asking me about presidents? Whoops. I mean, you're welcome, yes. I guess it doesn't need to be miscellaneous and stuff because presidents are part of stuff. They fit. Oh, so I've written the test, so I know exactly what it looks like. It's 3 15-minute segments. So we're going to be doing the probably the 5 multiple choice questions that aren't multiple choice first, and then probably the DiffEQ free response, like AP style free response, and then the area volume one. So it'll be all in each discrete section. And a reminder that the 2 later parts are going to be retakeable, the DiffEQ and the area volume stuff. In other words, this question and this question, but not exactly these questions. Man, you can't spell, Amy, I swear. You spelled glyph, G-L-I-F-F. This is glyph. See, all consonants. And then second one, snafu, spelled like that. Should our calculators always be that guy? Always in radians on the tests? Yes. What are we doing after the test, or what are we doing before the test? Probably ask a couple questions, and then I need to give a CHS update, and I need to talk about resources. So I have some extra resources and like some online stuff people can do. So I need to like start prepping we start reviewing for the AP tests sort of deal. So that's what's coming after the test, because we are going to have time. It's only 45 minutes. Oh yeah, chat's ahead of my voice, isn't it? By like 8 seconds. So my typing is confusing. Neither of the free response. These are no calculator, and this is calculator. So the calculator part is not retakeable. The no calculator part is on this. Got snafu from Kincaid. Will we be able to retake quizzes after the AP exams? Yes, May. There will be no retakes the week of our exam, but you can retake them the week before when there are AP exams. So there are retakes for, what is that? The next 2 weeks. Then we're taking a week off from retakes. And then we'll be back at it again. 16 through 20, 23 through 27. Because our AP test is May 9, which is really soon. Like 2 weeks from tomorrow or something. No, is that right? I think it's 2 weeks from tomorrow. Yeah, that is right. So we're a little behind. Longer breaks. Yeah, we can also do longer breaks, like have 2 or 3 minute breaks in between. That's fine, like bathroom breaks. Although they're only 15 minutes, so do you really need a bathroom break? Is there anything else I was gonna say about this? Oh yeah, so we're gonna be mock testing in class when we on Wednesday, Friday, and then Tuesday of next week. People who have AP tests are gonna miss the last mock test, and then the weekend before the AP test, so we're talking May 7th. This day, we're gonna have a mock test at school, so that's the Saturday before the calc exam. And it's going to be a self-graded calc exam because there's just not enough time given the schedule this year and the fact that like DECA's gone one weekend and all this garbage. So anyways, May 7th, there is going to be an after-school mock test. This is the most accurate to the actual AP tests, mock tests you can possibly take. Going to be this one, the May 7th one. We're going to take a reasonably accurate one in class. It's going to be a little bit older, and we're going to do the best, most recent one on May 7th on Saturday for that. And I'll give more information next time. And trust AP Chem is more behind. Yeah, true. I trust. Okay, so I think no more questions came in. I think I hopefully answered most people's questions. Yeah. I'm busy on the 7th. That's fine. Just that's the time when we're available. Kruzich and I will be here. We'll have overflow seating if there's need be. Wait, it's May 11th? Kruzich said it was May 9th. I wonder if Calc BC is May 9th and mine is May 11th. Is that actually the date? AP Calc 2020. Ugh. It's definitely May 9th. May 9 is our exam date. Definitely checked there. What if we don't exist on the 7th? That's pretty existential. What's open on your Steam page? My Steam library. SAT, it's May 9th. If you're taking the SAT during AP season, you deserve to miss this. No offense. That's like the worst possible time you could choose. Take it. Oh man. Holy smokers. Anyways, have a wonderful rest of your day. See you tomorrow. Hopefully this test won't be too intimidating or scary. And you just make sure you know how to do all the steps. Know how to solve a differential equation, know how to find area, volume, and all that stuff, and you should be all right. Oh, you trolled? Okay. Adios, amigos.